Hello everybody, and welcome to our last lesson for Chapter 6, 6.6 Inverse Functions. We are talking about inverse functions today, and they have something in common with the pairs of symbols or operations that I've written here. And adding and subtracting, multiplying and dividing, square root and squared. Hopefully you are thinking in your head, hey, those are opposites of each other, or they undo each other. And so today what we're talking about is entire functions, not just individual operations, but entire functions that are opposites or that undo each other. So they are opposites. And so for each ordered pair, x and y, the x's and the y's just simply switch places. All right, the graph of an inverse function is also an opposite or a reflection of the original function, and that occurs over the line y equals x, kind of a diagonal line on a graph. Our notation for an inverse function is f, -1. That's what it looks like, is a little -1 as an exponent, but you pronounce it as f inverse. The name is f inverse, all right? So let's take a look at a graph and a pair of tables here. So if you'll notice here on our tables, we have the actual equation for the function as well. And then we have a graph. So we have graph, table, and function, all three. And then our inverse is also represented in algebraic or function form. It's represented by a table and also a graph. All right, so let's take a look at the table and see what we notice. Notice that for every x value on the original function, it matches up with a y value on the inverse. And the opposite is also true. The y's match up with the x from the inverse. And that happens for all of the ordered pairs here. So just to reiterate, the x and y values switch places.